Alright, we're back 6.1, last portion, Algebra 2, right? Now, this is where the problems start to come in, right? You know, the first part was pretty easy. The second part, graph transformation, a bit tricky, but not that hard. Now, this part is where I also kind of struggled, right? Big thanks to Ihan. He gave a lot of the problems as well, which are solutions. So I'll just be explaining how the solutions work. Now, one thing for what is it? Question 13. Question 13 is omitted, right? Because apparently they think that the students in Shaheen are dumb bitches, right? It's not that hard. I'll quickly do it, but it's omitted, so okay. So this is just the answer for 13. You can. This is omitted, right? Omitted. So you don't need to do this, but it's good that you learned this because I don't know why they took the easiest word problem and they omitted that one, even though there are harder word problems. So we'll start with that, but for now, question 14 is pretty simple, so I'll explain that. Alright, so question 14. So this is just straight up algebra. It's not that hard. If you recognize the rules for 13, you could probably do this pretty easily. So now this looks familiar, right? So what can you do with this, right? You can use the same logarithmic uh, manipulation. So from here you can take the ln on both sides, right? So ln of 5, 2x minus 1, 2x minus 1 is equal to ln of 4x plus 3, right? So with the rule for, you put this back here, that comes here, right? So 2x minus 1 into ln5 is equal to x plus 3 ln4, right? Just putting this back here and like moving this bracket here, this bracket here. So we have this answer, right? So from here we can, we can easily just distribute this like normal. So this would be 2x into ln5. I'll write it down because it's easier. Probably just do this in my head, just so I'm not missing any steps. If I miss any steps, that's where the bad things happen. Right? So I had a little brain fart with my notes there, but yeah, it's pretty simple. So I just skipped the step in the notes. So this is going to be 3 ln4 and then plus x ln4. Now we have the common terms, so let's move them here. So 2x ln5 and then minus x ln4. So ln4 is equal to, this is going to stay here, so 3 ln4. Then this is going to be plus ln5, right? We just did some moving around. So, what is it? From here we can factor out these, right? So we can get just x then 2 ln5, right? Because this is just go inside, it's x, it's fine, is equal to, oh, sorry, forgot this, minus ln4, because this we're basically factoring it. Then this is going to be 3 ln4, no factor this one. We can't factor. ln4 plus ln5. I may do some sign mistakes, but it's the same answer. I just look out for that if I do any. I probably won't because I'm using notes for this. So now we have x, right? So we're just gonna x is gonna be equal to, you know, this. Move this down here, divide, right? So 3ln4 plus ln5 over 2ln5 minus ln4. You can just use the calculator for this and you will get the answer as x equals 3.147 and round it to two significant figures, so 3.15. That is what x is, that's the answer. So next one, question 15. This is where it gets a bit hard. Okay, so next one. This is where it gets a bit tricky with the word problem, right? So we know the formula for compound interest. You can check the question for yourself, like while you're studying, like watching the video. The question basically asks, it asks, so 20,000 is invested into an account and it pays interest. So the rate is 2.4 per annum, so per year. The interest is added at the end of each year. So remember that, that's important. So after how long will the interest be greater than 25,000? So remember the formula, we learned this a long time ago, right? So the amount, so basically total profit, is equal to principal into 1 plus r over 100 divided by t, right? So remember this formula. We'll have to remember this. A question like this is probably going to come in the exam, and you may not need to remember it. They give you this during the exam, but hopefully if they're like a good school, but I don't really expect much from China, however. So 25,000. And I'm gonna do this. I'm gonna do this side, the inequality side. So the reason why it's because it's asking at what point does this get greater than this, right? So like at what point does it reach, like how many years does it take to get larger than 25,000, right? So we can write down p, or we can write down 20,000, because that's we're investing 20,000, so this is the principal amount, right? Then 1, right, in the formula. And then it's 2.4, right? 2.4. Divide this by 100, you'll get, what is it? 0.024. And this is t, because we don't know t, right? So now we have something that we can work with. So 25,000. Equality. And let's move, like this is messy, so let's move this down here. So let's get this, right? This, cut this, cut this. So this is equal to 1.25, right? Because then you have 2.5 here, then divide that by 2, so 1.25. So 1.25 is greater than 1. Since I move this here, it's now 1.024. Because I'm adding these together, right? I'm adding these together, but I'm still going to keep the t here, right? So now what I'm getting is what I want to do is I want to find t, right? Because t is the main part of the, like, it's the main subject. I want to make t the subject. So like we did in question 14 and like other questions, we can find ln 1.25, right? And this is going let's say t to ln, so multiply to ln 1.024. Like I said, you move this here and then you find ln of this, right? Now what I'm gonna do, this may seem a bit weird, but since I'm now solving for t, I'm gonna replace the inequality here for in the equal sign, right? The reason why I'm doing that, you may not understand it, they'll probably teach this during class. the thing is, if I were to solve anything, like if I were to solve like maybe if this was x or something, or if this was x, like if this was x, or if this was x, I would have to keep the inequality. But right now I'm solving for the absolute value of t, so I'm gonna use a normal equality sign. Absolute value, like, yeah, the value of t. So this is ln 1.25. This is also 5 by 4, same thing. So then ln 1.024. And just plug that into your calculator, and you will get an answer of you'll maybe get 9.35 or 9.4. I got 9.35 for some reason, but that's because I did it like I was very messy when I did this. 9.4. I did this like 2 days ago. The next for A and B, for B and C, I did it like today. So for it's 9.4, right? 9.4 years. So first thing you might, since you're used to doing algebra, you're like, okay, maybe I'm gonna have to round this down to 9 years because it's weird to have just one, like to have zero point 0.4 years extra, or maybe you would try to put this in months, right? But no, it's actually 10 years. The reason the reason that it's 10 years is because they said that at the end of each year, that's when they start, that's when they add the interest, right? So that means it's 9 years, right? It's 9 years, but it's a bit extra than 9 years. So that means it's 10 years. So you always round up when you're like handling things like that, even if it doesn't seem like it should be like that. So it's 10 years. T is 10 years. Next thing is B. Now we're starting off for 15B. Now 15B is where it gets a bit hard, right? Maybe you understood, A pretty easily, but B is where it gets a bit weird. But it's not that weird. It's genuinely not that weird. It's just the word problems are a bit tricky. So they're asking, the question is, what percentage interest should be added each month if interest is to be accrued monthly, right? So we already know, since we found out here before, that it's going to be 10 years, right? Now, there is another formula for compound interest, right? And in actuality, since most of the time we find it per annum, which is per year, we'd use we'd replace this with t, right? But in actuality, it's nt, right? N is basically the amount that you're gonna get paid per year, right? So paid per year. So n is the amount of times to be paid per year, and then this is just years. Now there are 12. The question is asking. It's going to be accrued, which it's going to be basically added every month, and in a year there are 12 months, right? So we have 12 months. So n is just 12, right? N is just 12. But to make this equal, we have to multiply by 10, right? So it's 120. Now we have that. But the thing is, we don't have rate. We don't have the rate, right? So what can we do now, right? What can we do? We can do pretty much the same thing. Very similar. So put this down here, right? So this would be 1.25, just like normal. And we would have 1 plus, what's it? We'd have this, so 1 plus r over 100 to be 120. Now we don't like, we want this x1 to be down, like go down, because it's a bit messy. So I'm gonna use LG for this for the sake of diversity. You can use ln if you want. I don't care. So LG 1.25. I'm just using LG because that's what I wrote in my notes, whatever. So move this down here, 120, and then times 1 plus r over 100. Fractions seem pretty scary in equations like this, but it's not that bad. Now move this down here, right? We're gonna move this 120 down here, just like how we did here. So LG 1.25, and then divided by 120. That's going to be equal to. I should have put LG here. That's going to be equal to LG 1 plus R over 100. Now this is where it gets fun. So now we know that okay, let's switch sides here, right? So because we're gonna make this the subject. LG 1 plus R over 100 is equal to if we just did this in the calculator, it would be 8 times 10 minus 4, something around that. What my note says. So from here, we can see, hey, this thing was also in question 13, but I'll explain it now because question 13 is limited. So the log of base 10 of this, of 1 plus r over 100, is equal to this, right? That means, what that means is that it means 10 over 8 to the power of 10 minus 4. If we remember the definition of what a logarithm is, this is equal to 1, or to the 1, plus r 100. Now that's something you can work with. So what we can do is we can just move everything here. So we can do 10, 8 times 10 minus 4, or 10 minus 4. This is very freaky, but just ignore it. You can do it in the calculator. Then you're gonna multiply by 100 because you're gonna move this here. You're gonna multiply both sides by 100, and then you're gonna subtract 1 because we're gonna get rid of this. So now all we have is r. So what does r equal? R equals 0.1976 or something. Yeah. Which is, if you round this to two significant figures, 0.198. This is 3 significant figures, but the thing is, you could have done this like way quicker with another method. I'm not gonna mention the method right now because we can't use it either way. But what is it? We have to do it this way. This is how the book tells you to do it. Wow, no freedom of mathematics, whatever. So this is just 0.198% per month. I'll write that down. That's B. Now C is when it starts getting much more familiar. So we'll get into that. Now this is more familiar territory, so this is much easier. Now the question is, how long would the account take to reach 25,000 if the interest was added every month or every day? Every month. Yeah, every month. So that's for I. So what is a year? A year is 12 months, right? So this t divided by 12, right? That's pretty normal. Oh, a little mistake here. This is 20,000. So from here, since it's pretty familiar, I'm just gonna skip some steps. So ln of 1.25. Again, you're gonna put this down here. Then you're gonna find the log of ln of both sides, right? So ln of 1.25 is equal to ln ln of 1.024. I'm not going to skip this specific part because some people may not have gotten the hang of it. So ln, this is the part. So ln the 1.25, or ln of 1.25, then multiply, right? You should be pretty used to this now, right? Like by now. Multiply, so how did I write a B there? That's crazy. That's absolutely insane. Okay, so it's 1:22 a.m. It's actually pretty early for making these videos. So now we're gonna divide it. We're gonna divide this, right? So we're gonna find the reciprocal of this, right? So ln 1.25, and then divided by t over 12, right? So what is that? That is just the same thing as multiplying by 12 over t, because we're going to find the reciprocal. So I can just do this. I can just do t times 12 here. Or I can do times 12 anywhere, it doesn't matter. Times 12. And that equals to ln 1.024. Why do I see ln and ln at the same time? That's crazy. Okay. So t is equal to, if you just do some regular algebraic manipulation, you can find that t is equal to ln 1.25 times 12. We're going to write 12 here, it doesn't matter. Okay, you want to be fancy, put it in front. I'm just here to teach, so then ln 1.024. So then t, right? T is just, just do this in the calculator. It is 112.905 months, right? Then you're gonna round this up. Since it's not years, you can, round it. This is already rounding up, so it doesn't matter. So months. Now that's pretty simple, right? And next one should be the last hard one, right? So you don't need to worry after this. Okay, so next one. So the same question, but now they're asking for days, right? So I'll just quickly breeze through this. So then 1.25. This chapter, it's honestly, this is probably the most confused anyone has ever gotten. Like, I'm pretty sure this is the hardest chapter that you guys have done so far. But it's genuinely not that hard. And that's not, I'm not talking in like a snobby way, right? So you can find all of this. I have the same thing before. Move this up here. But I'm saying it in the way that, like, math was made scary, even though it's not, that scary. And if you learn to enjoy it, it's fun, right? If you look at the fun aspects of this, like, maybe moving, moving or understanding some concepts are hard, but like, as you get more used to the concepts, it gets more fun. Okay, now, whatever, shut up, nerd. Okay, so, ln. So you're gonna find the reciprocal of this and multiply, right? Just like we did before. So I'm 1.25. So we can just do 365 here and then find t here. T. This is equal to just ln of 1.024. You can see that we only really changed one small thing, and that only changed a small part of the answer. So t is equal to same thing we did before. ln 1.25 times 365 over 1.024. Now, if you just find this out, it's gonna be 3, 4, 3, 3. That's what, at least what I got, right? 3 days. Now, you may not get the proper answer, because the actual answer is 3435. Right. You may not get this is 2 days off, right? But logarithms, whenever you calculate logarithms, sometimes a very small percentage may be off, right? I use some calculators calculate some logarithms a bit differently. I use Wolfram Alpha for this, right? So I got 3433. If you get this wrong because of 2 days off, that teacher doesn't even have enough self-respect to teach math. So don't feel bad about it. If you're you could explain this. Say exactly what I said to your parents or something. If they see oh, you got it wrong, you got 5 marks gone. How dare you, right? Teachers just suck. Most teachers just suck. But okay, next one. Why am I ranting? Alright, let's quickly do these ones. So these are where it gets easy as fuck. Alright, so I wanted to say hell, but then it's so easy, might as well put some more emphasis. So 8, wow, okay. 8 plus 8. What is that? X. Yeah, 8x minus 6 is equal to 0. Now, same thing, we're going to do some substitutions. So, I think you guys did this before. So, substitution, so let's take u and make that equal 8x. Right? Therefore, you can see this is u squared, right? U squared. This is just u. Or this is 8. Yeah, this is u. This is minus 6, which is equal to 0. Now, whenever you see an equal to 0 thing, this is a very good sign. Whenever I see anything equal to 0, it's just like 20 endorphins just released in my mind because I know this is going to be easy. So, you're just going to use the negative b plus or minus square root b squared minus 4ac over 2a. Okay, so that's basically solving, but you just use that and you can get the values u2 and u minus 3. So these are the answers, right? B. This is gonna be okay. So okay. This isn't done. This isn't done, right? I should have done that. Now, 8x. For the first case, right? U is equal to 8x. So then u1. So 8x is equal to 2. Now we're gonna find ln 8x equals ln 2. So then x, move this up, move this here, equals ln 2 over ln 8, which is equal to what? That is equal to 1 by 3. Let's go here. So, yeah, this is answer. So this is x1, right? Now let's look at u2. So 8x is equal to minus 3. So then same thing, we're going to do x ln 8 is equal to ln minus 3. This isn't possible, right? We can't have this. So this case is invalid. We can't have this case. Therefore, only answer x equals 1 by 3. It's the only answer since this is invalid. You can't have anything, any logarithm to the negative unless you want like complex values. This is an answer, but you want complex values. So that's one. Now you may know what to do now, right? This is pretty simple. You do the same substitution, but this time u is going to equal to 10x, right? So now, u squared plus 6u, because you can see a 6 here, 6u plus 9 is equal to 0. Right? So from here you can get, I'll do this really quickly, u1 is equal to negative 3, and u2 is equal to, this is not a real value. This won't happen. If you put this in the quadratic form, this won't happen. Like, it's not in the set of real numbers. So what will happen is you have ln of minus 3, right? You can't find ln of minus 3 because the same thing happened. We got for a we got the second u to equal minus 3, right? So then we realized, okay, we can't, even if this was 10x, it's still not going to change it. This is going to end up with like x ln 10 equals ln minus 3. This is how it's going to end up. So you can't have that case. So that means B, no solutions. No real solutions. The school just takes no solutions as an answer. So I'm going to quickly do okay, so this is the next one. This is where it gets a bit trickier, but it's not that hard. It's actually shorter than those. So LG x squared minus 7LGX plus 12 equals 0. Now the LG, log of x, this looks scary. Again, this looks scary, but just look a bit closely, you can see, wait a minute, this is just, u equals lgx, right? So, from here, u squared minus 7u plus 12 equals to 0. Here, minus 7 into lgx. So, we can get the values of u1 equals 4, u2 equals 3. Wow, nice, right? So, for the first case, u1, case I should probably write down these are cases. So for I, LGX 4. Now LGX is equal to 4. So log base 10 of x is equal to 4. So what does that mean? That means 10 to the power 4 is equal to x, right? So therefore, x is equal to 10 or 1 followed by 4 zeros. Right? So 10,000. Now for the second case, this is going to be the same thing, right? LGX is equal to 3. So what that is just, what do you have to, yeah, well, you already understood from there. 10 to the power 3 equals x, therefore x is equal to 1,000. Right? That's pretty simple. This just looks scary. It's not that scary. Next one. Final one. 16D. Now, this is the final question for 6.1. This is one of the harder chapters, I won't lie. But, still, it's fun, right? What is it? 6.2 is going to be much harder, right? But still, it's going to be easy if you just understand everything. This is O levels, not A levels, right? So, again, what can we learn? LGX, that's a substitution. Just look a bit closely. So u squared plus 2u. This kind of gives me a smile on my face. I don't know why I feel so smug right now. So, oh yeah, our best friend 0, right? So, just to solve this, so u1 is equal to 2. u2 is equal to negative 4. Right? You may say, oh, look at that. Negative 4, that's bad, no case, right? No, that's fine. For this thing, it's fine because in other ones it was different. It wasn't log x. So, let's say for case 1. Case 1. LGX is equal to 2. LGX is equal to 2. So, that means it's LG, right? It's LG. We know the base. So, LG. So that means x is just equal to 100 because no, it's going to be 10 squared is equal to x, right? So x squared or x is going to be equal to 100. Then for I, LGX is equal to negative 4. Therefore, it's going to be 10 raised to negative 4 power, which is equal to, this. It's going to be equal to this. Yeah, it's going to equal to this. So if you just do that on the calculator, it's going to be 0.0001. This is the answer for D. And yeah, that's it. Not that bad, right? It's genuinely not a hard chapter. Just pay attention, right? Look for small details like this. Maybe for the where problem you probably mess up with stuff like not rounding this to 10, right? Because they'll cut marks for that because this is factually wrong, right? You have to do it at the rounding to 10, right? Then maybe just notice some small stuff like, oh, this is LGX, right? But I can also substitute this with like u equals LGX. Logarithms, they seem scary now, but later on they're kind of gonna pretty much be your best friend, so I don't need to worry about that. Yeah, I'm pretty sure. Like, honestly, the only thing you need to like learn is you need to learn the laws of logarithms and how graph transformations work. So yeah, uh, that's it, I guess.